just like to introduce now Chris Brauer from Goldsmiths, who's going to talk about wearable tech. So we're going to hear all about Google Glass and all of those kinds of things like the quantifiable self and jawbone and all those kinds of things, I guess. Chris.
Okay, thanks for that. Let me just see if I got the clicker here. Whoa. All right. So I'm going to talk to you about wearable tech and the evolution of cities. We've done 2 extensive wearable tech research projects. We started out looking at it from a novelty perspective. Then we did a really extensive global project around lifestyle and health and well-being. And now we're looking at productivity and performance in businesses in particular, but all organizations. And it's at that stage that, that our research is at. And I'm going to look at how we can connect some of our findings. One of the things we're starting from in this one is this Jeffrey West's research in Stanford, now at the Santa Fe Institute around cities, which if you're interested in cities, I'm sure you're familiar with, where there was sublinear correlation in energy usage in cities, which mapped almost identically to the sublinear correlation in biology. So example there, the cow that is 1,000 times heavier than the woodchuck will on average live 5.5 times longer and have a heart rate that is 5.5 times slower than a woodchuck. That's a sublinear equation, which looks something like that. And if we think about human life, it kind of flows in that manner where you start out and you're acquiring all your faculties and your capabilities, and then you shoot up and you live your life, and then at the end, you decay. One of the interesting things from West's research was that companies followed this sublinear relationship as well, decaying in net assets and 23 other metrics as they grew in size. So this is something we normally would just call the economy of scale, for example. So things get more efficient in their energy usage. But when it got applied to cities, then one of the findings right off the bat, as I mentioned, was that in energy use in cities, the sublinear equation works. So if a city doubles in size, it only requires an 85% increase in resources. And that applied to a huge number of metrics, some of which are listed there: gas stations, electrical lines, surface area of roads, carbon footprint, consistent sublinear, and West looked at thousands of cities around the world. There was a few outliers, but which are interesting in our case here in relation to innovation. But in general, this applied regardless of the geographic domain or the scale or size of the city. Now, there was other things, though, that didn't apply sublinearly, and these were kind of the productivity and performance things that happened in city, innovations, human activity, result of social engagement, things like crime, colleges, patents, wages. So if you're in a city that's twice the size, then the same job will pay 1.15 times as much. So this was superlinear scaling. So it appeared that with energy usage, cities scaled sublinearly, but with regards to things from human productivity effectively and innovation, there was a phenomena of superlinear scaling. So we can see one example here that was applied in that kind of context, which was the walking speed in cities. So heart rate versus the body size, this was the relationship that as the body gets larger, the heart rate slows, and therefore the energy use is more efficient. Alternately, in the walking speed in cities, as the cities grew, then there was a 1.15 time correlation. So if the city was twice the size, then the speed of walking on average in the city was 1.15 times. And there was a number of metrics, and this was remarkable, this kind of correlation between this biological law and the underlying foundation of what makes cities tick. Superlinear, though, leads to a kind of exponential curve and unbounded growth, and inevitably leads to collapse. And so West's research kind of pointed to the fact that, you know, with the Malthusian thing and resources running out, eventually we're going to see collapse. And so how do we deal with that? And from that, he talked about human innovation and this kind of constant need to avoid collapse by coming up with a solution. And we can see that from any aspect of, you know, the environment now, the things that are going on in China, in the cities that we're dealing with incredible pollution concerns and reaching a crisis point that seemed like there was a point of no return. And just before that point of collapse, then new innovations coming in play, which are transforming the fabric of the cities and their approaches and so on. So this kind of need to innovate leads to an accelerating cycle, kind of quickening, because as each time you find a solution, then the next solution comes up and is needed that much quicker, and that continues and continues in the hectic pace of urban life, as well as cities seek to deal with the fact that this unbounded curve is bound at some case to run out of resources and collapse. So I've been looking at essentially, can wearable tech be one of these things that can inspire a rejuvenation, a regeneration inside of cities, in effect a leaping innovation curve when cities get tired, when they get weary, and when they head towards that point of collapse. So we talk about this in terms of metabolism coming from the Greek, meaning change. And metabolism basically being those biochemical processes maintaining life. So if we think about urban metabolism and the metabolism of cities and the way that that works, then we can consider kind of what are some of the factors that influence the processes that maintain life inside of cities, and how can those things be impacted. One of the things about metabolism is it's really, really difficult to change in human life. There's very, very few proven factors that can influence metabolism. One would be, muscle mass, for example, over long periods of time. But it's very rare that you can actually change metabolism. What you instead try to change is energy consumption and efficiency. So in our example, that's food, and how much we eat and what we eat and how healthy the food and so on is a big metric that we can deal with and change, which can have a longer term impact on the way that we process energy. So in this context, I'm thinking about wearable tech as a kind of source of food, a source of fuel for cities, and whether that can lead to a kind of impact and sustainability. And on that end, I'm dealing with, this is School of Athens, and you have this kind of, in philosophy, there's a long-standing conversation, which is every debate comes down to Plato and Aristotle ultimately, and here in the middle of the picture, you've got Plato pointing up, talking about forms, and Aristotle pointing down and talking about particulars. And this is the kind of question around whether you're speaking of wearable tech or cities. Is the thing the city unto itself, or is the city just the result of the constituent parts that make it up? Is wearable tech anything meaningful, or is wearable tech the particulars, the devices, the various technologies that come together to make it up? And so when we talk about something like wearable tech, are we talking about the form of it, or are we talking about the particulars that make it up? So metabolism is actually better thought of in terms of anabolism, which is making big things out of small things. And so in a case that would be like, amino acids making up proteins and things like that in a metabolic cycle. In our case, I'm talking about the various types of wearable tech devices that we're researching with. We've classified them into 5 different categories, each one of them forming a different real function, and what I would say would be like the particulars of wearable tech. And together all these things roll up, and the particulars are changing all the time, and their uses and facilities are changing all the time. But ultimately, these little things, the devices themselves and the functionalities and the impact they have on human life, is what will make up the overall impact of wearable tech and its meaning. And in a relationship to cities, it's similar. We think of cities, and the people that make it up actually make the cities. There's many works that relate cities to living organisms and try to understand the dynamic of how they function based on the people that live within it. Similarly, wearable tech is a kind of combination of people and things, and together the interaction of those things. So what would be anabolic steroids for wearable tech? I have 3 areas that we're researching. Interconnections. Wearable tech is very, very weak right now on the connection to the cloud. Way too many ways in which the various devices are connecting, but also connecting to the city. And if we imagine, the smart city and so on, if humans are running around with the smart city, in the smart city, and the sensors are embedded in all the infrastructure, we can just think of these as sensors embedded on people. And if people make up the city and are the most crucial ingredient, then the communication between the sensors of the city and the sensors of the people becomes critical to the integration of the fabric of that city. Intra-connections, almost all the wearable tech devices don't speak to each other. That makes the kind of notion of a quantified self kind of absurd, because you're dealing with so many different interfaces and reporting mechanisms. We're working on a human cloud project where each individual will have a personal cloud where all their devices that they wear will correlate and be connected together. And then human cloud correlations. This is the notion of correlating productivity and performance measures in the workplace with the measures off the body. So if somebody is feeling stressful, if they're feeling stressed in the workplace, then we can correlate that against their performance based on the wearable tech data that comes off their body. And this is something that's immediately around the corner, around issuing a laptop and a mobile phone, and wear tech inside of an organization, and another crucial metric for big data. Catabolism, on the other hand, is breaking things down. So here we talk about things like wearable tech needs to be more beautiful. It needs to have more social grace, less intervention. We need to move up the stack away from hardware towards software. And we need to get clear what things are best to augment the human experience and what things are best to be automated. And wearable tech at the moment is struggling to sort itself through that. But in relationship to the city, of course, all these things make an enormous difference. This is the aesthetics and the functions of the city. So too, the wearable tech embedded within it. A smart city with smart wearable tech also carries those characteristics. Okay, last couple of things. Biofortification, something that we talk about where you can introduce a yam into a community that's already growing a potato. If that yam has vitamin A in it, then that can reduce the vitamin A deficiency in an infant population that's not taking breast milk. Similarly, is there a way to fortify cities using aspects of wearable technologies? Is there a way to create this notion of fortification, which is a simple intervention, replacing something that's already there with something that functions very similarly, but because of the wearable tech functionality built into it, it can serve an entirely different purpose. And epigenetics. So the blue-headed wrasse is a fish in the tropics that gets eaten. The male is blue and is electric and gets eaten all the time. As soon as the male gets eaten, one of the females changes sex. And this is a result of epigenetics or environmental changes that happen not to the DNA sequence, but turning genes on and off. What they're starting to find in early stages is that this is potentially hereditary. And because it's hereditary, each subsequent generation can take on characteristics. So in animals, if somebody feels stressed and anxiety, then their child or their offspring has those same characteristics of depression and so on that come with that, even if they haven't been in an environment of stress and anxiety, seemingly taking on the nurture genetical effects. And in a city, we can only imagine all the possibilities around that. Epigenetics for wearable tech in the city. And lastly, Moore's Law, we know driving this is a lot of the technologies as they grow and doubling all the time, every 18 months to 2 years, processing power of computers. One that's less well known is Wright's Law. He coined this in 1936. In airplane production, the labor requirement was reduced by 10 to 15% for every doubling of production. What this is essentially is a law of experience. With experience comes efficiencies, and that's the stage that wearable tech and the cities are at right now, is this point of experimentation and correlation between them. And that's the kind of area that we're trying to research, is understanding how we can learn from the experiences we've got. Thank you very much.